Good afternoon. So my name is Jim Scoggins. I am a senior principal data architect at City of Hope Hospital. City of Hope Hospital is a nonprofit. Oh, actually, before I get into that, let's talk about what we want to talk about, then I'll get into City of Hope a little bit. So the purpose of this discussion is go through the process that City of Hope went through as a greenfield customer of the Snowflake. We have a data warehouse, and we're wanting to move from on-prem to the cloud. But the idea is, like, hey, Jim, how much is this going to cost? I don't know. How much do you need to budget? I don't know. It's pay as you go. Well, you still got to tell us how much we need to put in the budget. So I'm like, okay, so we're trying to figure it out. And it's not like you can go take, it runs this on SQL Server, so you can run it like this over on Snowflake. It doesn't translate like that, it seems. So we're trying to scratch our heads a little bit and try to figure out, we didn't want to ask for too much and then say, no, we didn't want to ask for too little. And then all of a sudden we run through it, and then we have to go back and ask for more later. So what we try to do is take some actual workloads that we have, put them on Snowflake, and then just run the heck out of it and just try to saturate the machine at different levels of concurrency, different levels of sizes of warehouses, different numbers of clusters, so that we can actually have some sort of performance curve that we could use to make estimates based upon how many users and how much data and all this stuff that we're going to have. And all that's nice, but the bottom line was to get, well, how much money do we need to ask for the budget? And then also, when you actually get that money and you start using it, one of the things that might surprise some people sometimes is Snowflake customers all of a sudden, oh, I thought it was going to be $100 a month, and now it's $5,000 a month. So after you actually do your budget, you find out how much money that you need. When you're actually using Snowflake, you need to make sure that you kind of do some level of cost optimization and monitoring, just so that you can not get those surprises. So I'm going to talk about the first part of that. Frank's going to talk about the second part of that on the optimization bit. City of Hope, we're a nonprofit cancer research center. We have a campus in Duarte, California, which is about 20 miles east of Pasadena on the 210. It's in the San Gabriel Valley. So we have a great view of the San Gabriel Mountains there. The focus of, and we also purchased Cancer Treatment Centers of America. So rather than being California regional, we're nationwide now. And that's also part of the reason why we're going to, our current platform is like running out of gas. So we're moving over to Snowflake. So right now we have locations in California, Arizona, Illinois. We have 11,000 researchers, associates, scientists, doctors, and all that, because not only is it a hospital, it's also a school. There's a medical school there and everything. And it was, I think we're 110 years old now. It was founded as a what do you call that? A consumptive relief association. So people with tuberculosis, they send them out to the dry air in the San Gabriel Valley outside of you get them out of Los Angeles. So. And then we've grown into having a campus and all that. And actually, a lot of people don't realize this, but synthetic insulin was actually developed at City of Hope. So one of the reasons why I joined City of Hope is diabetes is in my family, cancer is in my family, and diabetes and cancer research is the main thing for City of Hope. For me, it was a little bit the personal mission also, in addition to working with some cool people and data. So anyway, we have, for our data warehouse, we have a diverse set of stakeholders. We have enterprise business intelligence that's running dashboards all over the place. We have research informatics, research operations, quality, clinical, marketing, population health, philanthropy, foundation. Philanthropy actually is a big revenue generator for us, because we, at City of Hope, we get a lot of donations as a nonprofit. And a lot of it from people in show business, for whatever reason, seems to be predominantly. And so we actually have a program where we want to make sure that our big donors are well taken care of when they approach the hospital. So we actually need real-time data for that. So if they make an appointment or their appointment gets adjusted, we want to make sure that our valet that's going to be there for them is there to help out. So we have not only just nightly batch stuff we have to worry about. There's purposes for near real time that we do as well. But so we have a whole giant set of stakeholders that we're doing both on the research and clinical and all that. So we need a platform that will be robust enough to handle different types of workloads. Our legacy data warehouse platform right now is a large CPU. There's 72 CPU SQL Server machine with tons of memory and terabytes of disk. We're currently using Informatica to do the ETL and Tableau to do the reporting. But we're just running out of gas with this machine. Part of it is there's a lot of workload. Part of it is the prior team before my boss and I came in had an architecture that was less than optimal that we've been optimizing, but we're using the opportunity to go from SQL Server to Snowflake as an opportunity to re-architect and make cloud native processes with a modern data stack. So right now we're using Fivetran to get the data to Snowflake. We're using Snowflake to house the data and query the data. We're using dbt to get it through the processing, and Prefect to do the orchestration of all that. So that's our new data stack. So we're going from ETL to ELT, which I'm sure if I asked for a raise of hands, how many people are using Fivetran, dbt, Snowflake, I'd probably half of you would raise your hand. So, and the other half would be Matillion or Coalesce or something like that. But the workloads are increasing. We're adding a new hospital in Orange County, down in Irvine. That's going to double the workload from City of Hope, and then Cancer Treatment Centers of America is going to quadruple the workload. So we're moving to Snowflake to do all that. But so now we're thinking, how do we size this thing? How do I go in front of the people that write the checks and say this is how much money I need and validate that? So one of the things that when we're planning this greenfield thing, I got to plan the budget. Snowflake has a pricing calculator. You go to Snowflake, it's easy. You just go put what you need into the pricing calculator, and it'll tell you how much you're going to need for the year. But how do you know what to put in the pricing calculator? How do you know how many clusters you're going to need? How do you know what size warehouse you're going to need? How do you know all that? That's the stuff that's hard. It's easy once you know it, put it in the, because we used the pricing calculator once we figured out what to put in the pricing calculator. But you got to figure out what to put in the pricing calculator. So, so what we did is we actually on our current, on the platform, on the SQL Server platform, we have, and probably like a lot of you have a bunch of different user groups. Maybe we had like 15 or 20 different stakeholder groups, but we have like 5 stakeholder groups that really use most of the machine, the 80-20 thing, right? So 80% of the usage is from a small amount of people. So what we did is we picked some workloads out of our heaviest users and we anonymize the data because we have protected health information and PII, personally identifiable information. So we use Protegrity to anonymize that data, so that because we didn't have an agreement yet with Snowflake when we were doing the evaluation. So we anonymized the data and put it up there and then ran the workload. Now, one thing I do want to thank is, so Snowflake was nice enough to give us some credits to be able to do this performance evaluation that we did. But it was actually, Snowflake funded that through Intel. Intel Corporation gave us like $10,000 to say, all right, here, go run that thing. So I want to thank, if anybody from Intel out there, thank you very much for letting us do that. So we didn't have to run it out of our credits. So that was very nice. But the idea is we wanted to get a really good estimate up front. Now, it's not going to be exact, but we wanted to get something. So one of the things that we tried to, we wanted to measure is response times. That's the biggest problem that we have right now, or before, sorry. I keep saying right now like it's now, but before was, the response times just got untenable on the previous platform, to where, things that used to take seconds ended up taking minutes, ended up taking hours, ended up taking days. And so what we want to do was take our heaviest workloads and just run the crud out of it and really take the Snowflake machine and saturate it as much as we can. So we got trying for the laser here. So what we try to do, can you guys see that laser pointer? Okay, great. I can't see it real well, but hopefully you guys can. So we did about 400 separate tests. What we did is we did a Cartesian product of the different warehouse sizes that we, from extra small all the way to large, the number of clusters, and we did a concurrency test on different sessions. We went all the way from one query at a time to over 120 queries all running at the same time, and then we tested them at tables at 58 million rows, 232 million rows, and 938 million rows, and this is the JSON that we had for the prefect that we did configuration. So all this stuff was automated. We were thinking about using jQuery, but one of the smart kids that was out there saying, well, what do you need? I said, we need to do this, this, and this. And then he came back like 3 days later and said, okay, I did it. And he wrote it in Python and prefect. It's really good to have those whiz kids out there that can actually just start hammering this stuff out there. So we didn't need to go get jQuery or anything, because this query driver that he wrote in 3 days actually worked, and it worked well. There's a couple times it fumbled, and he fixed a piece of code, and then it worked. So it was pretty cool. So, but one of the things we made sure we did, so we can actually do the analysis, is we made sure that every single run had used query tags, so we can see what test, we named each test separately, how many clusters we're running, how many concurrent queries we're running, how many total sessions that we're running, and this was the configuration file that we used to do that. So what we found, the other thing, when we're measuring response time, one of the things, we want the average response time to be X. Well, you might not want to use average response time. Why is that? What we found is when we started running all this stuff, when you look at the curve of your query response times and you look at the mean, our median was right at the mean, which meant if you tried to use average response time as your SLA, that means half of your queries met your SLA and the other half did not. So you don't want to use average if you have the median and the mean of your response time. So what we did is we actually found out how fast did 95% of the queries run under. So, so for example, when you had about a 3.5 second, when we used an extra small for this particular set of tests, we had a 3.5 second average. But if you wanted to say, I want an SLA where 95% of my queries run faster than that was actually close to a little over 6 seconds. So whereas had we gone in using 3.5, we would have had like half of our users disappointed. And so we wanted to make sure that our users were not disappointed. So we went with the more stringent 95% ran faster than this metric. So we did that, and because just do the average response time. I said, let me think about that. So what are some of the things that we found? The interesting thing is on Snowflake, one of the things we wanted to test is how well did it scale out. So if we had a level of concurrency, we wanted to make sure that as we increase the workload, we can maintain the same response time as so which means adding clusters. Because when you add clusters, it'll help you add concurrency. What we found is it does it pretty well. So we did tests. We started doing tests with 1 cluster, 2 cluster, 3 clusters. Then we found, oh wow, this seems pretty linear. So we just said, you know what, we're going to shortcut it. We measured at 1, 4, 7, and 10 clusters, and we found that overall, it's not exactly flat, but that's close enough that you can really count on if you have a certain level of concurrency at the cluster level, you can take that and scale it out, and you can use that math to scale out your calculations for how many concurrent queries that you can use. So what we did is we normalized on something that we're calling, where's that? I have it somewhere else, but I call it a cluster concurrency. So I'll get to that in a little bit, but what we found out is you can actually, if you know how much you're going to need for one cluster, you can use that to calculate what you're going to need, how many clusters you're going to need as a whole, if you know how many queries that you're going to have running at a given time. Did I want to see anything? Okay, yeah, all right. So now, scale up was a little bit different. What we found when we ran just, like one query. It's whether you ran an extra small, small, medium, or large, they pretty much all ran at, with one query, they ran pretty much the same time. So if you wanted to make your query faster, and you're not going to have a lot of concurrency, it's really not going to help you to increase for our particular workload. Now, it's possible that if we had a petabyte of data, that going to the larger warehouses would have made a bigger difference. But at our dashboard sizes, it really didn't make sense to, where we started seeing the difference is we increased the level of concurrency inside a cluster is where the things started to be a big difference. So to speed up a query, so we found that interesting because the story is usually you add clusters to get concurrency, you make bigger warehouses for faster response time. We found that at the lower levels of concurrency, it's not quite the case. It is at the higher levels of concurrency. So your mileage is going to vary depending on your workload and the type of data and how much data that you have. But what we did out of all this is we actually we ran all those tests and we put it, and we built a spreadsheet of what our costs would be at different levels of work. So we'd say like, all right, so with extra small, medium, large, if we had cluster concurrency of X, then here's the response time that we can find. And I'm actually going to go through some examples to kind of make this come alive a little bit. But we're able to use this to start saying, all right, depending on how many users we have, we're going to have some level of concurrency, and based upon the response time SLA, 95% response time, then this is how much machine we're going to need in order to get this workload done. Like, so for example, if we had 160 users, which means we'd probably need about 16 concurrent queries running at any one time. Because, when you're doing dashboard stuff, the user's not going query. He's using query, it comes out, there's some think time, he's looking through it and all that. He or she is looking through it, doing all that. And about 10 seconds later, they'll send another query. So what we found within City of Hope is a good number for us is for however many users there are, we need 1/10 the number of sessions. So we had a 10-to-1. 10 users, one level of concurrency, 20 users, two levels of concurrency, and so that. So if we have 160 users, we have 116. Your mileage may vary. You might have it, so what you want to do is you want to look into your current system and find out how many users do you have, how many of them are connected, and then how many queries are going on active out of those number of connections. And then you can start gauging what your concurrency ratio is going to be to your number of users. And you use that as a figure for doing these type of calculations. But in this case, so we have in this case, we have a 4-second SLA. So in the Tableau report, what they want is 4 seconds inside of the database and give 4 seconds for Tableau to render to bring the thing up in about 8 seconds. So they hit it, and 8 seconds later they have the thing. So, and if we had 16 concurrent queries, 160 users, let's kind of look at what our little table tells us. So on an extra small warehouse, if we ran 6 clusters, we'll get it done in 3.93 seconds response time. So we can run, also let me tell you, the reason why there's $4 here. I put the retail for business critical. So, since we're a hospital, we have to be HIPAA compliant. And business critical, it allows us to keep our own encryption key so that Snowflake doesn't manage the encryption keys, we manage the encryption key so that we can guarantee that nobody else can see the data. So, but unfortunately, business critical is the most expensive. Like, the standard is $2 per credit, enterprise is $3 a credit, business critical is $4 a credit. So we're running business critical. Now we got a discount, but I'm because of the commit that we had, but I'm just using the retail number here. Our numbers will probably actually be a little bit lower because of the discount that we got with the level of commit that we did. So we looked at this and we were like, okay, extra small warehouse, we can actually meet the SLA with 6 clusters running, so it would be $24 an hour. If we ran a small, it would take 4 clusters to do it, so it costs us $32 an hour to run that. A medium, 2 clusters, we'd have a 3.5 second response time. All of these meet, even though these are different numbers, all these meet the SLA. That's what we're trying to do, is meet the SLA. We're not looking for the fastest. Thank you. Yeah, we're not looking for the fastest. We're just looking for what meets the SLA. And then similarly, if our SLA was 3.5 seconds, then the extra small warehouse, every single one of these are $32 an hour for us to run, okay? And then, but it turns out they're all the same to run. Okay, if they all cost the same, that's when you want to start saying, okay, what's the speed? Who's the fastest at that point? So at this case, there's a 2.79 second response time with eight clusters, 3.1 second response time with 4 clusters, and now I was going to talk about horse trading, but because 3.1, because it might be that here you could actually get it to $24 an hour. You could actually have the small warehouse be the cheapest if you said, all right, instead of 3.5, if I can go 3.56, if you let us slide on 600ths of a second, I can actually run one less cluster. I can run 3 instead of 4. And if you let me give you 15 concurrent queries instead of 16, if you're okay with that, I'm going to save you 25%. And that's the conversation you can have with your user base, your stakeholder base. I can save you 25% if you'll take it, 600ths of a second slower. They always say yes to that, because so. Part of this analysis is not only trying to find the cheapest and the fastest, but also what compromises can you make with your stakeholders. So that's why I wanted to give this example. Also, same for when we start getting bigger, 24 concurrent queries, 240 users, what ends up being the both extra small and medium ended up being the fastest, but this is the fastest at price parity. So extra small warehouse, 8 clusters, medium warehouse, 3 clusters, but you get it a little bit faster. So in this case, for this particular workload, you'd want the medium warehouses because it'll give you your SLA, but with a little bit of horse trade. With a little bit of horse trading here, you can actually get, same price, but you can get a lot faster. But if you don't want a horse trade, then you just go with the ones, these are 3.5, no, none of this. This one was supposed to say 4 seconds. I'm sorry about that. So my apologies. This is supposed to be, the next one's supposed to be 3.5 seconds. My apologies. I had a typo. I thought I got all the typos. I put in my last thing this morning. I thought I got all the typos, but I didn't. But anyway, but that's the idea. Once you've built out this matrix of what your performance curve looks like, and then you start actually applying to what workloads you're going to have, then you can actually start building out the figures that you need to put into that pricing calculator. So anyway, that's kind of what I wanted to talk about a little bit. Now you're going to say, hey, Jim, what about auto scale? Why don't you just set a size and let it auto scale? Absolutely. That's what you should be doing. But you still, before I could even let it auto scale, I got to tell the accountants how much that I might spend. And so I had to do all this anyway, just so I could come up with the budget and of how much money to ask. Not all workloads will be the same, but if you actually, part of the reason why we did this also was, if they say, well, how did you come up with these numbers? If you can actually show them that we had some method with some math and some method to the madness behind it, then it's a lot more acceptable for the folks that are approving your budget than if you just said, I took a guess. And they say, well, are all the workloads going to be like that? Well, no, they're not. Not all workloads are going to be this exact workload, but this is something to work from. And you know what? Most people find that reasonable. And that's what you're looking for. You're looking for a level of reasonableness. And also when you're wanting to add other applications and stuff like that, you can use that as a baseline. Maybe the baseline goes up, maybe the baseline goes down, but you can use that as a baseline to start with. I know my portion's out of time, so I'm going to just tell a few more things. Joint elimination just came out when we were doing this, and so that really helped a lot. The joint elimination. So we were already doing partition pruning and that worked, but then the partition pruning with the joint elimination actually worked a lot. One of the things I also want to talk about was the commitment on the budget. So when you have a budget, do you, and let's say you say, hey, I'm just going to use a round number, $10,000. Do you commit that whole 10,000 to Snowflake, or do you say, I'm going to hold 5,000 back, and then I'm going to keep 5,000 in my pocket, and then if I undershoot my rollovers, I'm not going to have that much rollover, but if I overshoot, hey, I got more money in my back pocket I can add to the contract. Or do you do pay as you go? It's up to you. But at least when you're trying to figure this out, it gives you an idea of where you can start doing the negotiations with Snowflake. Now, this is what we did to come up with, here's how much we're telling our bosses, here's how much Snowflake's going to cost. And Frank's going to tell you how we actually make sure that what we told them actually happens. So, thanks,
James.
Yeah.
Well, hello, Data Nation. Thanks for coming, like you said, during lunchtime on Thursday. My name is Frank Bell. You might have seen I've been working with Snowflake since beginning of 2018. I had run my own consulting company from 1999 to 2019. I was one of the, let me see if this works. Yeah, there you go. All right. So basically, I've been running this consulting company. We've been doing all sorts of stuff. Mostly data warehouses for Fortune 500 companies. We've done Oracle, Netezza, Teradata, and then we came across Snowflake. And then actually James didn't do too much on his background. We met when I gave a Snowflake Data for Breakfast. I think it was 2019. Yeah. So basically, when I came across Snowflake, as many of you might have seen, it was just revolutionary for us because we had never seen a technology that could scale to do all the things that we wanted to do. And while it's awesome, I say, that saying, with great power comes great responsibility. And so about 2 years ago, we started building this Snoptimizer so you can get Snoptimized, which is just really, it's a lot of the other things you'll see out there from Capital One and others is more cost. Ours is really about the balance of cost and performance, as well as looking at security. So we combed through those account usage views and used some of the Snowflake user-defined functions to really get to the bottom of how can you right-size your Snowflake account level and organization level next. So, but James didn't talk. One of the reasons why we hit it off is he was old school, like he worked at Teradata on the Walmart projects in the 90s. And so he really understood the bare bones, the hardware side of things. And we kind of immediately hit it off. And that's why his presentation is so technical, because he goes into deep understanding. And we do the same thing on the back end for the right sizing. So we're going to go through right now right size Snowflake for cost and performance. I'm also going to teach you a little bit on cost allocation techniques. We're expanding that, and that's really like how do you charge back if you have a chargeback model for your company or organization. One of the newest functions and features that really we've been asking for about 4 years has come out with Get Query Operator Stats, and that lets you really dig into what's happening on the back end of your query. And then I'll talk a little bit about this tool set we built, which is really like automated Snowflake optimization, allowing for both recommendations and automated corrections to happen, which a lot of people, believe it or not, I mean, how many of you have, let me ask first, how many people have used Snowflake for more than 2 years? Like half. And then, or the rest of that. And then how many of you have really spent a lot of time on the account usage views? A decent amount. Well, I always thought that was one of the best things about Snowflake. The amount of metadata that they provide is pretty amazing. And so let me just jump right in then. So there's actually some additional ones, but here's the main cost areas. So those of you who've worked with account usage views, you know a lot of this already. So when we started in 2018, really it was storage consumption and query consumption. Cloud services hadn't come about. That really came about when Snowflake realized there was a lot of these tools are just pounding the metadata all the time, and using too much of that. So they built up something, if you're over a certain percentage of cloud services, then you get charged for that. And then replication came later, Materialized Views came later, search optimization, pipes were kind of in their infancy then, and automatic clustering. So my point about this is, it's awesome, Snowflake, and even 2018, 2019, when it was just really a cloud data warehouse, I pretty much understood almost every aspect of it. But as it's grown and grown into a data cloud, there's no way any one human can really focus on it. And so I have experts I go to for Snowpark, and a lot of my expertise is around optimization. That's why I think about day and night. And then I've done a lot of work I did some of the original R&D for building out the original data clean rooms, and I helped build out the Snowflake, at the time, Data Exchange in 2019, then Data Marketplace, and now Marketplace. So my point about this is it's just gotten more and more complex. So these are the two areas, though, if you're going to really center around anything and try to understand, like, where am I going to get the most cost optimization, it's really to focus on these, and really query consumption. The other things I mentioned, though, too, are important, because what we see is people like, all of a sudden, oh, they get on materialized views, they get on auto clustering, and all you need to do is have a bad, we call it anti-pattern use case, right? If you use materialized views on something where the data is being inserted in not the same order, and it's just every hour, it continues to materialize that. So that's going to start to add up in those costs. And the same thing for auto clustering. I mean, the more you pour into it, and the more on the back end, I'm assuming most people here know, one of the fundamental technologies of Snowflake was micro-partitioning. That was probably the most key foundational thing. And it's awesome, but if you have massive time travel and you keep changing those tables, all those clusters are right ahead. I mean, all those micro-partitions are right ahead. So there'll be thousands, you could have millions of them if you keep changing that data and you have like a 90-day time travel. So here is probably the most beneficial thing if you really haven't done much. For you veterans, you probably have done most of these, but I am still amazed at the number of places we go into that are not using resource monitors correctly. Like, I honestly just can't believe it. And it's been this way for 3 or 4 years. First we did health checks like 4 years ago, and then we started this Snoptimizer tool set. So the first thing to do is create resource monitors. And then the next thing to do is actually make sure they're set with the correct settings. Like, I don't know how many places we also go into that have a resource monitor set for like the month. Like, and I've seen so many, over the years, so many just dumb, if you get an out of control query, if you have a boss change an XS to a XL, 6XL now, like you go, this is the awesome part about Snowflake, like it's fundamentally amazing, but you can also go from spending on an XX with 1 credit to 512 credits in the same hour. So you just 500x your cost, and you can do it in milliseconds. So you have to have the right controls set up, otherwise you have massive costs or risks is what I call it. So the other first thing to do is, I don't really completely agree why this should be set to 48 hours, but that's the way it is. That's the way it's been for 5, 6 years I've been working on it. Not that many people need to have that across every query. And so you can either set it at the warehouse, we typically just immediately set it to like 2 hours across the whole system as a baseline. Then if you want to get more into heavier customization or optimization, you can set up for each different warehouse. And then the other thing we see a lot, it's still, from what I tested last, it's either defaulting to 5 minutes or 10 minutes. The reality is, especially if you're doing ELT warehouses, that's just a waste of typically, if it's 10 minutes by default, 9 minutes, because after you load something, you do not need that warehouse to stay up. And so at first, this even adds up. Think if you're doing an ELT load every hour. And so there you have 24 hours and then 9 minutes wasted all the time. So there's just easy fixes. they've come out with a new create and monitor budget functionality, and if you paid attention or heard, but it's in private preview. Another big thing that we're excited about is they've come out with warehouse utilization. It's only in private preview right now, so if you are interested in that, our Snoptimizer will have an end. Feel free to, I think I'll have my email at the end, or reach out to me on LinkedIn and I can help you either get your private preview with that new tool or set you up a Snoptimizer demonstration or automation. So again, these are like I said, everybody has like cost savings, but it's really, to me, a balance of performance and cost savings. So it's like, what do you want to have? And similar to how James's metrics worked is like, can the user deal with a 4-second or a 5-second SLA? And these things are very similar too. Like, okay, you set up, do you really need this materialized view because it's going to cost you $1,000 a month? Like, what's the business value? And another thing, if you follow me, my biggest thing is, because I have a kind of a unique background of, I was in the Air Force, I ran my own company, but I also have an MBA, and I also have a bachelor's of electrical engineering. So I look at things differently. So everything to me is a business and performance and tech trade-off. So all these things, while awesome, like, do you need to pay for search optimization? What's the value to the business? So you'll see me write a lot about, my main concept is data to value. How long does it take to get your data to value? And another thing I'm writing about is, I'm really frustrated with all these people like, oh, there's bazillion petabytes, all this data. Like, I don't care how much data there is. How much are we using? How much actually is bringing business value, bringing human value? So these are all awesome. But again, I always look at all 5 of these, and there's more actually now, as just business to performance technology trade-offs and cost. So for those of you, this is an interesting topic, and I'm actually surprised that Snowflake hasn't built anything. So we're working on this as part of Snoptimizer as well. We're starting to get requests from a lot of companies like, well, you know, we usually do chargeback, and this is how we do it. And some of that stuff is relatively easy to start off with, but we're making a more complex model. Because a lot of times, sometimes people just put each warehouse into different business units. But I'll just show you some simple things that you can do to, if you want to do your own simple, like, cost attribution to different business units. So these are the typical ways that we go about it in like a standard model. Like, you either have attribute cost by the users or roles, and they're set to specific units. The way that we get more granular is we use query tags, which will show another example of that. But it's really about thinking about what logical cost units can you figure out. And the problem is, right, some people are in this department and help out with this department, so it gets harder. And so that's why we use, this is just an example of what you can do. And we have a much more elaborate schema that we work with you and just go through, what are your business requirements, what are your business units, what are your cost units, how are these people allocated, and we give you a framework to work with. So that concludes that part. And then, so this is awesome. I mean, I love a lot of the announcements, the NVIDIA. My biggest thing now is native apps. I think it's going to be game changing for our whole data professional industry. But this was like, I've been asking for this since 2018. And they finally gave this user function. And I'm just going to cover real quick. But if you have not used this and you're into optimization, especially on the query side, this is amazing, because this is the only thing that really gets you deep into that query and understand it. And this is just like the top part of this. You can get the details on the aggregate, what's happening, the Cartesian join, the delete. These are just if these items have been used, how much time is allocated to it. So it basically takes all that visualization of a query profile and it puts it all in the data. And so this is why I love this, because I don't know, I just never, I like query profiles, but it seems like so, I don't know, 1990s or 2015 or before. Because I mean, it's great to see that visual, but I want to do automation. I want to do AI. And so this gives me the ability to look through different queries and provide recommendations to them. So this is just an example of all the details in there. And it's amazing. Like I said, to get this before, there was no other way you could actually do it until just now. And that brings me to like the final part. So any of you that are interested, feel free to come to me afterwards. You can go to the site and sign up for a demo as well. We basically spent like the last 18 months. We've had this in production for about 8 months. And there's a couple players out there, but really what we're looking to do is like optimize all these different pieces. And again, we look through the very, very in-depth details across the account usage. It's always funny, like I wanted to give you enough information, but I don't want to give you like all the secret sauce that we're doing around warehouse utilization and how you can take multiple warehouses and condense them into one because you've got like 5 different warehouses at like 10 or 20% capacity, or you're doing stuff in serial when you can do it all in parallel. There's a lot of things under the hood that I love Snowflake, but it doesn't really expose except when you get into the metrics like us. So if you've gone to these things, the experts are, if you're new, these are the typical things like that we can help you control. We give you basically automated fixes for most of them. So if you ever see queuing and spilling, I've already talked about resource monitors and auto suspend and warehouse optimization. These are the types of things that we fix for you. And then we're not like some of these very in-depth security checking, but it still amazes me again how many people have messed up RBAC models or role-based access control models. And so we just look at the basics of what you're doing. And the biggest thing we're looking for too is what's your cost risk? Because if we get in there and we see, oh, there's 30 people with sysadmin and they all can create everything up to a 6XL on AWS, like that's a problem. And so those are the things that we try to root out and make sure doesn't happen. So we've actually got this next example. We've gotten like up to 60% cost savings. It's just the number we usually use. Like unless you really, really optimized, we can always get over like 5%. And most places, I'd say we average like 20%. And then again, it's a balance of not just cost, but security, performance. And then if you haven't done this, this is just a fun little thing about, hey, here's the views that we're using. And I think the big benefit, even if you do your own custom optimization, is we're just thinking about this 24/7. As the warehouse utilization comes out, we're on top of that. Like all the new changes, that's really what Snoptimizer provides, is a way to just always be continuously updated, to have something always looking at your account usage. The biggest thing we used to come across and why we started to build this was we do these health checks, and it's like we do it with Snowflake, and it'd be like this one-time fix, and then like a month later, someone goes in and creates another warehouse and doesn't follow the recommendations, and then you're back to problems. And again, like I said, I love Snowflake, and cost-based pricing is awesome until it's not. If you've ever had a utility bill, and more, I had one when I moved into a house. The previous owner had a huge leak, and I had like a couple $1,000 bill, and they remediated it, but it's like something you gotta just watch out for. You want to keep it down. So anyway, I gotta buzz through this so I can wrap up because my time's coming up. But this is just an example of another customer, how we cost optimize them, and we got like 55% savings off this one. So I think my times are, I have like 20 more seconds. Here's like if you want to scan this, or just go to snoptimizer.com, or you can hit me up on LinkedIn. But thanks so much for coming, and I hope this was useful to you and you enjoyed it.